Assalamu alaikum, dear students. Welcome to quantum lectures. In this, we will discuss the solution for the problem 3.21, which says that consider a system which is initially in a state psi at t is equal to 0 and having a Hamiltonian. We are given with the state psi which at time t is equal to 0, which is this, and Hamiltonian h is this. If a measurement of h is carried out, what value we obtained and with what probabilities. Okay, we have to find the per eigenvalues of h, and then we have to find their probabilities. Find the state of the system at later time, as we will use definitely the time dependent Schrodinger equations. You may need to go expand psi of 0 in term of the eigenvalue of h. Okay, and then see, find the total energy of the system at time t is equal to 0 and later time t. Are these values different? Okay, does h form a complete set of commuting operators? Okay, if eigenvalues of two eigenvalues of h are similar, it means they will not have commuting operators. Let's go to solutions for the first part. First, in order to find the possible value of a measurement of h is carried out, we have to solve the eigenvalue problem of h. So h psi 0 is equal to e psi. This is done by solving the equation for the eigenvalue of h as in the matrix representation. So we will form the first the secular equations for the Hamiltonian, which will give us this determinants form. And if we seek for a linear independent eigenvalues, linear independent values, so it will give us three values, because this is the 3 by 3 matrices. Definitely it will give us the three eigenvalues. So the first E1 is 0, as you are observing, and other two we find by quadratic formulas. If I maximize it so that you can see it, so the other two eigenvalues will be obtained from the quadratic formula. A square minus 3u under 2 e minus 5 is equal to, using the quadratic formula, this will give us e1 is equal to 0, e2 is equal to this, and e3 is equal to 5 under 2. So we have obtained eigen energy is equal to this, e2 is equal to this, and energy 3 is equal to this. Okay, if we proceed for the second part, in order to calculate the probability of obtaining certain value of energy, we must find the eigenvectors. For the probability, first we have to find the eigenvectors. So for the energy E1 is equal to 0, eigenvector will be equal to, for example, let we represent with states psi 1, A1, A2 and A3. So h psi 1 should be equal to E1 psi 1. H is the given operators and psi 1 is unknown matrices and is equal to eigenvalues E1, which is 0, and psi 1 is the unknown vector A1, A2. Okay, if we multiply something with 0, definitely it will go to 0. Therefore we have write a 0 on the right hand side. Okay, multiply this whole set of matrices just by ordinary methods of eliminations. We will have three equations and three unknowns, so this equation can be solved by any methods of the equations, linear equations. So this will give eigenvalue as a2 is equal to 0, a1 is equal to 3 iota a3. So our first eigenvector will be equal to a3 3 iota this, and for finding the values of a3, we will definitely have to lead to it. This will lead us to the normalization constant for the normalization condition, because if we have to find the values of a3, definitely for psi 1 and psi 1, this probability should be equal to 1. So psi 1 and psi 1 will be equal to 1. It means if we this is the cat form, and we take it we can take its bra form. So multiplying both with each other, this will give us the total probability is equal to 1. In normalization constant should be 1. So we can multiply this will give us the value of a3. So we can use this value of a3 in this will lead to us the value of psi 1. so psi 1 is equal to this. And for energy 2, we can we can proceed with the similar methods for finding the value of b1, b2, b3. So this will again gives b to psi 2 is equal to b2 and this. So for finding this b2, we will again normalize this vector. We see that b2 is equal to this, because we can normalize this psi 2, and psi 2 should be equal to 1. So we are given with the psi cat. If we take its bra and multiply with cat and bra, it should be equal to 1. So this will give us the value of b2, and substituting this value of b2 in this will give us psi 2 state at psi 2. Similarly, for E3, we can adopt the same procedure, and it will use the third eigenvector psi 3 is equal to c2 minus iota phi, and the for finding the value of c2, we will again use the normalization method. Psi and psi cat should be equal to 1, and if we take the we are given with the psi cats, if we take its complex conjugate and multiply with, this should be equal to 1. So this will lead the values of c2 as we have done in the previous questions. So I am not going to repeat it. C2 is equal to 5 over under root 5 to under root 11. The third eigenvector is this. Okay, then now the final part is the probability of obtaining specific eigenvalue is P1 is equal to phi1 psi of 0 whole square and psi of 0 and psi of 0. Similarly, probability for A2 is equal to probability for phi2 psi at psi of 0 modulus square by psi of 0. Similarly, probability for E1 is equal to for E3 third phi3 psi of 0, psi of 0 and psi. This is the normalization constant. If normalization constant is equal to 1, then it will be definitely equal to 1, and we will have to put 1 here. And for this phi1 psi of 0, we can find this phi1 and psi 0 and its modulus square, because this is phi1 and this is psi of 0, and definitely we will take out to modulus square, and psi of 0 and psi of 0 is equal to 1 over under root 5 over 2. So this will give us probability 0.25 for the second probabilities. For the probability for the second energy is equal to 0.2, and similarly for the third we have probability 0.55. Okay, to find the function at later time, we need to expand the initial state in terms of the eigenvector. So psi of 0 is equal to 4 minus iota minus 2 plus phi of 0. We can write it like if psi 1 plus b psi 2 plus gamma psi 3. No a, beta and gamma are unknown, and we can put the values for psi 1, psi 2 and psi 3. So psi 1 is given, psi 2 is given, psi 3 is given. It should be equal to this psi 0. So comparing these two equations for these three equations on the left side and on the right side. So this is three complex algebraic equation which can be solved for alpha, beta, gamma, because these are three equations and three unknowns. So this can be lead us to value of alpha, beta and gamma. So for alpha, those equations are pretty hard to solve, so we will skip the analytical solving. You could try using some mathematics software if you want to solve for alpha beta. We will just apply the evolution operator. We can find the evolution operator, because if we are given states at psi is equal to 0, we can find state at later time by applying time evolution operator, which is u of t. So you know that evolution operator is equal to exponential minus iota t h cut over iota t h over h cut, and psi of x is equal to 0. So if we apply this will give us psi of t is equal to alpha psi 1 and beta psi 2 exponential this, and gamma psi 3 exponential iota phi iota t over 2 h cuts. Okay, then for the energy in the beginning is E0 is equal to sum of I is equal to 1 to n p n e n. So for the first if we write it, P1 E1 plus P2 E2 plus P3 and E3. So E1 is 0, it means this will go to 0, and similarly E2 is this, and this is probability P2, and similarly E3 and P3. So this will give the initial energy is equal to this 2.22. Okay. For the last, since none of the eigenvalues of the Hamiltonian of the system is degenerate, the eigenvector psi I is equal to 1 to 3 form a complete set basis, thus H form a complete set of commuting operators. Okay, so I will stop at this point.